Welcome back, folks. I had added another problem that I usually don't do in the mesh analysis section, but I wanted to show you how to find the voltage across the current supply. We're not going to take it that far. We're going to go find the mesh currents, because once you do that, finding the voltage across the current supply is the same. But I just don't want to leave it out. Okay, we already worked it once when we were introducing mesh analysis a few videos ago. Let's work it again here. All right. So, does it look familiar? It should. If it doesn't, go back and look at some videos, because it's in there, I promise you. All right. Orange. Let's try white. Okay, so once again, oh, this one's not labeled. That's fun. And we got 3 by 3. We'll squeeze it all in here. And a 3 by 1. And then I'll keep writing down there. But this is essentially the information we need to work in, and then we'll solve it and we'll get the solution. Because that's what you do when you solve things. Okay. Okay. Let me just make sure I labeled my the mesh currents the same way, because that could change the problem a little bit. So let me take a quick peek at that and just make sure I'm not leading you astray, if I can ever find the problem I'm looking for. All right, hold on, folks. I got it. Okay. I just want to make sure that I'm consistent in how I label these. There's no right or wrong way. If we're doing the shortcut, they all have to be in the same direction. So I'm going to make them all clockwise. But there's no reason that I can't just swap mesh names, mesh current names, however it suits me. But I want it to be consistent with what we did before, so that when I make that comparison at the end of the video, it actually does line up. That's why I went and got that. Okay, so I've got 3 unknowns, so I got a 3 by 3 system, 3 by 1 vector over here on the right. Don't forget to invert it. Got to invert it. And I see 1 current supply, so one of these is going to be a KCL. Okay, and that's for the super loop. And we say, does I1 touch it? Nope. Does I2 touch it? Yep. And it goes in the same direction. Does I3 touch it? Yep. And it goes in the opposite direction. And the right-hand side is just 6 milliamps. Pretty quick, hopefully, after I did my fumbling early on there. Okay, writing the KVL for the super loop, I'm going to follow this path. Okay, and following that path, let's see, what does I1 touch that's on the super loop? It looks like it touches these 2 4Ks, and I1 is not part of the super loop, so I'll add those together and it'll be negative, so it'll be negative 8K. What does I2 touch that's on the super loop? It looks like it touches these 2 4Ks, and I2 is part of the super loop, so that one's just going to be 8K. And then what does I3 touch that's on the super loop? And it looks like it touches these 2 4Ks, and it is part of the super loop, so it's going to be positive 8K. All right, right-hand side, it's a KVL, so we're going to work our way around, and we only cross over this voltage supply, and we cross from the negative side to the positive side. So that's going to be positive 12. All right, KCL, this was the KVL for the super. Squeezing that in there. And then we need a KVL, and the last one we need to write is for I1. So this is going to be the KVL for I1. All right, what does I1 touch? It touches 8K, right? That 4K and that 4K. What does I1 share with I2? It shares the 4K here, and it's shared, so it's negative. And then what does I1 share with I3? It shares this 4K, and it's negative because it's shared. Looking at the voltage supplies, it looks like we go up across this 12-volt supply. Okay, and there's our system. So let's solve it. Put my calculator over here. You should be doing this too with whatever tool you intend to use. Right? I hope I've said that enough. I will continue to say it. I want you to practice with the tools you're going to use when you need to do this on the spot. If that's for my exams, that's great. If it's for the FE exam, you should be using that calculator. If it's for your job, go ahead and use whatever you want. If you want to use MATLAB or Python or anything like that, you're welcome to do that as well. Just make sure you get the right answer. Make sure you can do it when you need to. Okay, let's see here. Yeah, this looks good. Can I squeeze it in up here? So this is going to be I1, I2. I think I can. Woo. And I3. And what is it going to be? Close. 4.5 mils. There we go. I got to stay in there. 4.5 mils. 6 mils. And our favorite, 0. I'll just write amps for that. Could be milliamps too. Okay. That's it. What are we at? 6 minutes? And I did a lot of talking. I know you think I did a lot of talking too. And let's see here. Let's go look at our previous result, as I like to do. So from our previous problem, or our previous video, working the same problem, it's going to look like this. Come on here. Look at that. And we ended up with an identical result. 4.5 mils, 6 mils, and 0 mils. And our system looks... Oh, no, we flipped these 2 rows. And we got a lot of negatives, but if they're all negatives, we're okay. We got the same result. So, can't argue with that, right? So this is from our previous video. Okay, so hopefully you're getting comfortable with this idea. I'm going to use it when we start moving on to the theorems and some of our more complicated analysis. I'm going to use this, and that's really why I want you to be comfortable with it. And I want you to know that it comes from KVL, KCL, and Ohm's law. I'm not doing anything crazy. It's all coming from those fundamental laws of circuit analysis. It doesn't just come out of nowhere. Oh, am I behind that? 4.5, 6, and 0. Sorry, my big fat head's in the way. All right. Now I'm going to show you some problems, and I'm going to show you why I don't use the shortcut. Because if you have a tool, you should know when to use it and also when not to use it. So probably one more video on that. We'll see. But stay tuned and good luck.